In the following example, we're asked to find the area under the curve y equals x squared plus x between the x-axis and the line x equals 7. Here we have the graph of x squared plus x from our graphing calculator. As well, we've used the calculate function, so second function, trace, and choosing the integral of f of x dx option to integrate from 0 to 7, and we can see the area here. So the result we should get is 138.833333. So to solve the question, we find that the area is equal to the integral from 0 up to 7 of the function x squared plus x dx. Integrating gives us x to the 3 over 3 plus x squared over 2, and that has to be evaluated from 0 to 7. Now we use the fundamental theorem, which tells us to plug in the 7. It gives us 7 cubed over 3 plus 7 squared over 2. So plug in the upper limit and subtract the function with the lower limit plugged in. 0 cubed over 3 and 0 squared over 2. This term is 0. So that gives us 343 over 3 plus 49 over 2, which when we work that out gives us 138.83 repeating, which is the answer we expected. In this next example, we're asked to find the area under this curve between 0 and 3. Again, the graph from our graphing calculator. In this case, we've had to adjust the window to go from 0 to 4 on the x-axis and from 0 up to 350 in the y-axis. So this is the shape we get. We shade beneath the line to the x-axis, so beneath the curve to the x-axis. We find the answer should be 281. Approximately. So when we do the answer, we find that the area is equal to the integral from 0 to 3 of this function, so 6x squared plus 4 times square root of x cubed plus 2x plus 3 dx. Now integrating, for this function, we need to choose a technique. We notice that if we choose u equal to the part under the root, then the derivative of u is a multiple of our pieces that are left over. So we take u equal to the part under the root. Du then is 3x squared plus 2 dx. And if you look at the piece we need 6x squared plus 4. Here we have 3x squared plus 2. We need twice that, so 2 du is equal to 6x squared plus 4. Multiply both sides by 2. Now we can substitute. So substituting 2 du for this piece with this, and u for the part under the root, so we get u to the half times 2 du. We ignore the 2, so we're going to get 2 times u, add 1 is 3 over 2, over 3 over 2. The whole thing is evaluated from x equals 0 to 3. Now I emphasize x here because we don't substitute in for u. We have to first put the x back in, then substitute for u, or for x. So we end up with 4 over 3. 2 comes up. This is x cubed plus 2x plus 3 to the 3 over 2, and that's evaluated between 0 and 3. Plugging in the value, we can leave the 4 over 3 outside of everything because it's constant. So we can put here 3 cubed plus 2 times 3 plus 3, and that's the power of 3 over 2. And then we have to subtract 0 cubed plus 2 times 0 plus 3, and that also is to the power of 3 over 2. Close the big bracket, and working that out, we get 4 over 3 multiplied by the first bracket gives us 216. The second bracket, 0, 0, and 3, so that's 3 to the 3 over 2. And multiplying all that together gives us 281.071797, which is the answer that we can get from the calculator.